Okay, so tonight for your homework, we are going to finish our journal activity, which is titled Earth's Smooth Move. So when you left, we pretty much just had our sun glued down and we were working on our tabs. If you understand the process of tabs, go ahead and finish it. Remember, this first page was the one that we cut completely off. This is kind of like our cover page. And then I'm making 4 tabs on the side, one for each season. So write the title, Earth's Smooth Move. On here, we're going to talk about 3 important vocabulary words, which by now you've probably should know. Rotation, revolution, and orbit. So rotation is the spinning of the Earth on its axis, which causes day and night. We then talked about how the Earth makes one complete rotation every 24 hours. Now, the difference between rotation and revolution is the motion of the Earth around the sun. Again, it is moving around something. It takes the sun about 365 and a quarter days, which is 1 year, to complete. And the path that the Earth takes around the sun is called the orbit. Now, the orbit is this line that I have drawn right here. It is a curved path that the Earth follows around the sun. So here are your 3 vocabulary words. So if you need to pause the video, take your time, write it, and then you can hit play again. So you're going to need to practice that throughout the whole time. Don't let it get ahead of you. Just pause when you need it. All right, so let's go ahead and take the cover page and let's take it back. Okay? You should all have an Earth, and what I want you to do is, because this tab right here on the side says summer, I'm going to label this page summer at the top. You should still see your sun in the middle. Now, we know that for us to have summer, and we're going to go with the northern hemisphere on this one because that's where we live and that's what we're going to care the most about for right now. How does the Earth have to be tilted for the northern hemisphere to experience summer? Well, the answer is it needs to be tilted towards. So I want you to take your Earth and you need to glue it so that the northern hemisphere is tilted towards the sun. Now make sure that you do have a tilt going on. Your Earth should never be straight up and down because remember, if our Earth wasn't tilted, we would not have seasons. So once you have this glued down, I want you to take a yellow marker or a highlighter or something, and I want you to shade the half of the Earth that is facing the sun yellow. This represents day, where the other side that is not yellow represents night. And remember, what causes day and night is the Earth's rotation. Now, the first day of summer is a very special day. It is called the summer solstice. And solstice has a special meaning. Now, the first day of summer can actually occur anywhere between June 21st or June 22nd. So I want you to look at the northern hemisphere, okay, and look at the part that we colored in the yellow. Would you say that we are receiving a longer day or a shorter day? So what I mean is I want you to look at this section right here that is in daylight compared to the section that's in night. We're having a larger amount of day because in the summer we're tilted towards the sun. So what is special about the summer solstice? It is actually the longest day of the year. Okay, and what also is pretty cool that in the northern hemisphere, days last more than 12 hours because you can see that these 2 halves right here are not equal. So in the northern hemisphere, days last more than 12 hours. But I want you to look at the North Pole right here. Notice how if the Earth was continuing to rotate and spin from day and night, the North Pole is always going to be in the light. I mean, look how much light is after the North Pole. So on the actual first day of summer, which is called the summer solstice, the North Pole experiences a 24-hour day. meaning it will never get dark at the North Pole on the first day of summer. So if it's experiencing a 24-hour day, that means it is experiencing a 0 night. And the reason why this happens is because the sun, right here, if you look at our arrow, strikes the north hemisphere the most directly, right at the Tropic of Cancer, which is 30 degrees. So because it is hitting the earth most directly in the northern hemisphere is the warmest, so therefore that's summer. Okay, so if you need to pause the video to write any of this stuff down, go ahead and do so. If not, we're going to move on to the next season, which is fall. Okay, fall is just around the corner for us. So I want you to, on this page, title it Fall, and you need to cut another earth free. However, we're not going to place it over here on the left-hand side like we did before, because our earth is always going to stay tilted in the same position. So where do you think we need to place our earth for fall? Are we going to put it at the top or at the bottom? Well, if you keep in mind, everything in space rotates and revolves counterclockwise, so that means we're going to put it on the bottom. Okay? This day is called the autumnal equinox, which stands for autumn. Now, equinox is a very special word because equinox means equal, just like equator, equation, equinox. So on the autumnal equinox, something is going to be equal. And this day occurs anywhere from September 21st or the 22nd. Now on this picture, I had to just kind of draw a circle around the earth to represent day, because the actual side of the earth that's facing day is the other side that we can't see because this is a two-dimensional picture. And then the side that we do see is night. So what can you think is going to be equal? If it's the equal, now we know that this first day of summer was the longest day of the year. So it can only be the longest. So after that, it's got to start getting shorter. So the days are constantly going to get shorter as the earth is revolving. And then right when it gets here, where it's not tilted towards the sun and it's not tilted away from the sun, the day and night are exactly equal. And that's what we mean by equinox. So everywhere on the earth, everywhere, from the North Pole to the equator to the South Pole, everywhere experiences exactly a 12-hour day and a 12-hour night. So again, because it is the equinox, everywhere on earth is experiencing equal day. And this is at all latitudes.
Where is what's her name? Hannah and the old kids.
Now, if you look at the sun, you probably notice that the earth is getting struck, like, be over here on the other side. That is right at the equator. So because the sunlight strikes the earth the most directly at the equator, neither the northern or southern hemisphere is receiving the most direct sunlight, so neither one of them are in summer. So if you need to pause the video to catch up on this, make sure that you're doing that, and make sure again that your earth is tilted. So let's go to winter. So make sure you're on your winter tab and go ahead and write winter at the top. So by now you should probably be able to figure out where is our earth going to be. Our summer was over here on the left. Our fall was down here on the right. Well, we're going to keep moving in that counterclockwise circle. So now we are going to be over here on the right. And the first day of winter is called the winter solstice. So notice that winter and summer have solstices, which means they are the exact opposite of equal. They are as far off as they're ever going to be. The first day of winter is anywhere from December 21st to 22nd. Now make sure you do color half of your earth in day that's facing the sun and the other half in night. So if we were to look here in the northern hemisphere, notice how much of the earth in the northern hemisphere is in day. Would you say that's more than half, less than half, or equal? Well, it should be a lot less than half, making the winter solstice the shortest day of the year. And if you probably read into your mythology with Persephone, you could figure out why they believe that. Okay, so what else is special? If you notice, a day lasts fewer than 12 hours. And a night lasts longer than 12 hours. And you probably all realize that it's always darker in the winter. That's not just because of daylight savings. That is because we're tilted away. Now let's look at the North Pole. Notice it right here. If the Earth is constantly rotating and spinning at the North Pole, this North Pole is never going to move all the way over here in the light. So on the very first day of winter, which we call the winter solstice, the North Pole is experiencing a 24-hour night. And the same is always going to be true for the South Pole, but at opposite times. So if we're experiencing a 24-hour night at the North Pole, then the South Pole is experiencing a 24-hour day. And if you were to look at where the sun hits most directly, it hits down here in the southern hemisphere, which is called the Tropic of Capricorn. So because the sun hits most directly in the southern hemisphere, that hemisphere is going to be the warmest, which makes it summer, and it's hitting the absolute farthest away from us, which makes it winter. So whenever we're tilted towards the sun, summer, away, winter, neither. It will either be fall or spring, depending on the way the Earth revolves around the sun. So just figure out what season was before that. Okay, but definitely make sure that you are keeping up with the hours of day and the North Pole. So then the last Earth is spring, and I'm actually going to write spring at the bottom. And if you could figure out why, it's because my Earth is going to go out on top. All right. So we call the first day of spring the vernal equinox, because vernal in Latin means spring. And it is on March 21st or 22nd. So now, just like when we were doing the fall, the side of the Earth that's facing the day is all I can see with this two-dimensional. So this side is day, and I wrote the other side is night. And again, because the sun is hitting the Earth most directly at the equator, and this is a equinox, that means everything is going to be equal. So you have 12 hours of day, 12 hours of night at all latitudes. Okay? So pause the video if you need to catch up on this, or rewind it for any part that you need to go back through. So if we were to go through the whole thing again, summer is when you're always tilted towards, and here are all the reasons. And then it goes to fall, winter, spring. Okay, I really encourage you guys to go back over this and look at it, because there are going to be a lot of pictures on some of the assessments where we're going to, you're going to have to be looking at certain cities based on their latitude and figuring out if they're in day or night and what season. All right, well, that's it, and I will be checking this first thing in the morning, and we will start the lunar cycle tomorrow. If you haven't come up with your big product yet, really start talking to your group because, again, that is due Thursday. Y'all have a good day.